Section 5, the last section of the chapter, is called geometric series. So section 4 was arithmetic series. If you remember back to sections 2 and 3, it was arithmetic sequence and geometric sequence. And then section 4 was arithmetic series, and now we're doing geometric series. So based on that, what are we going to be doing in this section? Working with geometric sequences. But instead of just sequences, what are we going to be doing with those terms? When we find a series, we are doing what to our terms? Adding them together. So we're taking a geometric sequence this time and adding all the terms together. A geometric series is the sum of the terms of a geometric sequence. Get yourself a geometric sequence and add them all together, and you got yourself the answer to a geometric series. Okay, we need to remember what a geometric sequence equation looks like. It's been 2 days, so. It's right here. A sub n equals a sub 1 times r to the n minus 1. The nth term, a sub n, of a geometric sequence is this guy right here. A sub 1 is the first term, still. R is called the common ratio instead of the common difference, because we're not adding or subtracting numbers, we are multiplying them. And n is any natural number, any term number along the way. So for example, suppose you send an email to 5 of your friends. Then they forward that email to 5 of their friends. How many people will receive the email after the 8th round of emails following that pattern? Well, how many people got the email in the first place? In the first place, you got the email. So 1. And then you sent it to 5 of your friends. So how many got it that time? 5. That's really as far as I need to go here. All we need to know is the first term in this sequence, and then we need to know the common ratio. So then we can write our equation. Well, I'm writing a sequence right now, but you're right. The series would have plus signs. All right, so we have the email. Now let's read the problem and make sure we understand what's going on here. Suppose you sent an email to 5 of your friends. All right, so round 1, how many emails were sent? 5. We did get the email, but that's not round 1. That's us getting the email. So is that our first term? Is 1 our first term? No, not the way this is written. So we're going to cross that off. But how many do we have for our next term? 25. So after round 1, 5 people have our email, and then they send it to 5 of their friends. Well, if 5 people send 5 emails, that's 25 emails. So that's why term number 2, round 2, is 25. So now we know a sub 1, which is what? 5. And we know what? R equals... How do we calculate R? Well, you can go one of 2 ways. You can either say the term times what gives me the next term, or you can say this guy, any term divided by the term before it gives me the common ratio. That's usually how I go. So 25 divided by 5 is 5. And now we know everything we need to know to write our equation. A sub n equals what? 5 times 5 to the n minus 1. There's your equation for this situation. Now the question says, if the pattern continues, how many people will receive the email after the 8th round of emails? So on round 8, how many people get this email? We plug 8 in for n. A sub 8 equals 5 times 5 to the 8 minus 1. which is like 5 to the 7th, and then 5 times 5 to the 7th is like 5 to the 8th. So enter that into your calculator. What do we get? What is it? 390? 625. So 390,625 what? People or emails, yeah. How many people? It says 390,625 people get that email. It's a lot, and it only took 8 rounds. So that's why when you get your chain emails or whatever, and it says, if you pass this on to 10 of your friends, blah, blah, blah. Yeah. Okay, we could not do a series on that problem because as of right now, we don't know how to add up all the terms in a series. So that last problem was just a sequence. Now I'm giving you the formulas for a geometric series. And notice that they're different than the formulas for an arithmetic series. We do have 2 formulas here. The first one is if you are given the first term and the number of terms, then S sub n equals a sub 1 times 1 minus r, the common ratio to the nth power, divided by 1 minus r, the common ratio. Or if you're given the first term and the last term, then this is the guy you're going to want to use. S sub n equals a sub 1 minus a sub n times the common ratio, divided by 1 minus the common ratio. So notice the similarities in both. First of all, they both have this denominator, 1 minus r. Both of them have the first term involved in them. This one has a sub n because you were given it. This one has n because you were given it. But what else do you have to have in both equations in order to use them? You have to have the common ratio. If you don't have the common ratio, you can't find the sum of a geometric series. So we will have to find that. Okay, let's go back to the email example. How many emails would have been sent after the 8th round? Now this is asking me total. It's not how many people get the email in the 8th round. It's how many times has this email been sent. So what do we know? We know a sub 1, which is 5. The common ratio is 5. 5 people get this each time. We know how many rounds we had. 8 rounds. So what do we do? We don't know the last term, technically. I mean, we calculated it, right? So we actually could use this one here because we do know what a sub n is because we've already found it. But right now, with this information that we have sitting here, can we use this one? No. Can we use this one? Yes. So this is the one you'd want to use in this case. So I'm going to write S sub what? 8 equals the sum of the first 8 terms in this geometric series equals 5 times? No. 1 minus 5 to the 8th power divided by 1 minus 5. All right, then you just evaluate that down. Or you plug it into your calculator. Or you do it in your head, if you know what 5 to the 8th power is. $488,280. 488,280 emails. This is total, right? What? This is the total number of emails, and the total number of times this email has been sent since I sent it 5 times. Not the total number of people who get the email in the 8th round. That's different. because in order for us to get to the 8th round, a bunch of other people had to get that email in the 7th and 6th and 5th and 4th and 3rd and 2nd rounds. We're adding all of those numbers together to see how many people now have received this email total. And right now it's 488,280 people total, assuming no repeats. Should this number be bigger than the number of people who got it in the 8th round? No? Yeah, of course. Because the number of people in the 8th round is going to be less than the number of people in the 8th round plus all of the other people who have also received the email. Okay, so there we go. Now, we did calculate how many people got this email in the 8th round. So we actually do know A sub n. So just to see if this one works, we should get the same answer. Let's go ahead and use this one. We'll have S sub 8 again for the second equation equals A sub 1, which is 5, minus, what was A sub n? Okay, and then we're multiplying that times what? The common ratio is 5. It's not 2 to the 5th, it's just times 5. Divided by, yeah, that's just times. A sub n times r. Divided by 1 minus r, which is 1 minus 5. So we type that into our calculator and really hope that we get the same answer. We do. Same result. So both equations work. Both are just fine. One is no easier than the other, really. It just depends on the information that you have at hand. And you need to know how to use both of these at all times for this section and then for the test and quiz. Well, just like last section, we had some sigma notation to work with. And the same thing is true here. So sums and sigma notation using a geometric series. Same idea as before. We still have the same letter, the same Greek letter sigma. Sigma is our notation for when I want to add up a bunch of stuff. And that's what we're doing here. 4 times 2 to the m minus 1 is the equation that generates the terms in this series. M equals 3 to 10. So we're starting at term number 3 in the series, and we're finishing up at term number 10 in this series. Basically, that's what that's saying. So what is the common ratio in this situation? 2? Why? Okay, all right, so 2, fine. What is the first term in this series?
4.
The first term in this series. For them is 4, but for us, it's not. Because we're actually starting here. Our first term is different than their first term. If we were starting at 1, then our first term would be the same as their first term, which is 4. How do I know it's 4? That's the long way. How do I know that the common ratio is 2? That's also the long way. The short way is to remember the formula for a geometric sequence, which is a sub n equals a sub 1 times r to the n minus 1. That's exactly what we're looking at right here. So therefore, a sub 1 is 4, and r is 2. Or you could have just looked down here because they're all listed right there. So r is actually the base of the exponential part of the function. In this case, it's 2. So we know r equals 2. A sub 1 normally is sitting right here. So normally a sub 1 would be 4. But our a sub 1 is not their a sub 1 because we are starting at 3. So we have to take the 3 and plug it in. 3 minus 1 is 2. 2 squared then is 4. 4 times 4 then is 16. So our a sub 1 is going to be 16. That's where we are starting to add terms together. That's one side effect of bad notation. Okay, how many terms are there? In our situation, there's 8 terms. Because we go 10 minus 3, which is 7, plus 1. We get 8 terms in our situation. So that's n. And again, I had it listed out right here. But anyway, now what do we do? We want to find the sum. Pick an equation. Yeah, can we use either one, or is there one that we know better than another? We don't have a sub n, yeah, so we're going to use the first one. And just to refresh our memory, since it's on a different page, s sub n equals, what are we using here? They both have 1 minus r in the bottom, but what's the top? R to the n. So then substitute that stuff in. How many terms do we have? 8 terms equals our a sub 1, which is 16, times 1 minus r, which is 2, to the 8th power, divided by 1 minus r, which is 2. So the denominator is negative 1. The numerator, we have negative 2, well, so we have 2 to the 8th, then 1 minus 2 to the 8th. 2 to the 8th is 2, 4, 8, 16, 32, 64. 128. 1 minus 128 is negative 127. But if I divide by negative 1, it becomes positive. So I have 127 times 16. What do we get? Like 4,000 something. 4080? So 4080 or 4082? Okay. Bring up the calculator, and we have 16 times parentheses 1 minus 2 to the 8th power. Get out of the exponent, get out of the parentheses, and then we're dividing by negative 1. Enter. 4080. So that's how you do these. Identify the stuff that you have. Use this formula right here, but realize that if you're not starting at the first term, then this will not match your a sub 1 that you use for your formula here. Okay, what is the sum of the finite geometric series? Remember that word finite means what? It does end. Now notice that we have a dot, dot, dot here. That just means that I have a bunch of missing terms, but it does not have a dot, dot, dot here. If it had a dot, dot, dot here, then that would mean that this series does not end. It would continue on forever. But because it's just that last term without the dot, 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 then it does stop. And the same thing happens here. We don't have a dot, dot, dot at the end. So let's see if we can piece together this sum. What do we need to do? Our a sub 1 is 3. Equals 3072. So they actually gave us the last term there, very kindly. What else do we know? We don't have a common difference in a geometric series. The common ratio r is 2. 3 times 2 is 6, times 2 is 12, times 2 is 24, and so on. Do we know anything else? Do we need to know anything else? That's all we need to know. Are you sure? Okay, so what equation can I use? The second one. S sub n. But aren't I supposed to know how many terms there are? No. The last term is 3072, not the 3072nd term. Do I need to know the number of terms?
No.
I don't. That's something unique to the geometric series. I don't have to know all the terms. S sub n equals what? Mm-hmm. So 1 minus 2. It's always 1 minus r in the bottom. S sub n, however many terms there are, I don't care. I can add them together right now. Type that into your calculator carefully. We have a negative 1 in the bottom. 3072 times 2, probably like 6144. So 3 minus 6144 is not. Negative 6141. Divided by negative 1 becomes 6141. Oh, gotcha. Mm-hmm. Okay, how about that second one? Actually, we know quite a bit of stuff here. All I got to do is find the sum. How about we just add them all together? We don't have any missing terms. There's no dot, dot, dot like this one had. This one starts and ends, and we see all the terms here. What do we get? 369? There's no need to do all this fancy math if we know all the terms. And there are so few terms, it's easy to just type that stuff in. So do it that way. If you wanted to, though, you could do exactly what we did over here. We'd write S sub 6, because we have 6 terms, equals, and then use whichever equation you wanted to use. Maybe we'll use the same one we used over here. The first term, negative 15. Then what? Yep. Times the common ratio. By the way, this is a mistake here. There should be a 60 there. Otherwise, it's not even a geometric series. So there's a typo. The common ratio here each time is we're multiplying by what? Negative 2. Divided by 1 minus negative 2. So now that that is actually a 60, this number right here changes to what? 315? Okay. All right, so we have negative 15 times. We have minus a negative, so it's going to be plus 480 is probably like doubled would be 960, and then minus 15 is probably 945. Divided by 3, right around 315. So you get the same answer. With very few terms like this one, go ahead and just add them together. But the sum formula will still work. How about these bottom two? We want to find the sum. What should we do? Please just plug it into your calculator. You're given summation notation. There's no reason not to. So type it into your calculator for both of those, and what do we get for the first one? What is it? 21? Okay, what do we get for the second one? $17.05. That's what you got? Huh. Well, okay, so we can't trust you today. Let's go with some notation, and we want n, and we're starting at 0, so watch out for that. And we're going to term 20, and then we have 4 times 1 divided, whoops, I need to put that in parentheses. 1 divided by 2 Then outside the parentheses, we're going to the n power. Press enter. Oh! Yeah, let's convert that to a decimal. Oh, it's 8. So what do we get for this one? Oh, it's negative 1705? You told me 1705. So there you go. If you're given something that looks like this or like this, use your sum formulas. If you have just very few terms, go ahead and just add them together. If you don't know all the terms, you're going to be forced to use this. Or if you're given sigma notation, go ahead and type it straight into your calculator and come up with the answer. 8 through 16, how many problems is that? It is 9. Good job. 16 minus 8 is 8, but then we got to add 1 to it to account for the one that we missed, just like we're doing here. How many terms are there in this series? 21. Because 20 minus 0 is 20, but then we got to add 1 to it. How many terms are in this series? 10. Because 10 minus 1 is 9, but then plus 1 is 10. How many problems are there? Oh. 16 minus 8 plus 1. 9.